In this video, we are going to talk about Venturimeter. Venturimeter is a measuring device, basically. And what it measures the velocity of the incompressible fluids. Suppose you have a pipe. Water is flowing through this. These are the streamlines. These streamlines, they never cross each other. Correct? Now you want to find out what is the velocity of the flowing water inside this tube or any liquid inside this tube. What you can do is you attach Venturimeter in between the pipe. Now fluid will be flowing through this like this. In this Venturimeter, one end is broad and this middle portion is constricted. It has got a smaller area. Suppose here at point 1, area is A, and point 2, area is small a. And as per continuity equation, we know that V1 A will be nothing but V2. Suppose V1 and V2 velocity at 1 and 2. So naturally, from here, your V2 is A upon A into V1. This is due to continuity equation. Now, we have attached between point 1 and 2, 1 manometer, and we have a fluid here with density M, rho M. This is a broad end, and this at point 2, it is the small, having a small area. Naturally, if you see the continuity equation, velocity at point 1 will be less, and at velocity at point 2 will be more because of this equation. But here, let us see what our Bernoulli equation says. Now, since they are at the same level, point 1 and 2, so this potential energy part we can strike off. So with this equation, suppose velocity is more, then naturally pressure will be less there, and velocity is less, pressure will be more. So with this analogy, pressure at point 1 will be more because velocity here is less. And due to this, what it will do? It will apply the pressure in the manometer, and due to this pressure, at point 1, pressure is more. So this liquid will rise like this. And suppose this height is h. Then let us see pressure at P1 minus P2, because pressure at 1 is higher. This must be equal to, as per manometer principle, rho m g h, and this must be equal to your half. What is P1? P1 plus half rho V1 square is equal to V2 plus half rho V2 square. Correct? That means P1 minus P2 is nothing but half rho V2 square minus V1 square. And we have this formula. We can replace V2 when half rho V2 is nothing but A upon A square minus 1. You can take V1 square outside. Correct? So this is your, here it will come as R rho A minus 1 V1 square. Correct? So V1, which is the velocity, we have to find out, because it will give you the velocity inside the normal pipe through which we have attached the Venturimeter. This will be nothing but square root 2 rho m g h upon rho A upon A minus 1 this this will be, and this will be like this. Correct? So this is how we can find out the velocity V1 and this, just by attaching the Venturimeter. We know manometer density. Whatever liquid is there inside the manometer density, we know. Density of the fluid in the pipe also we know. We know the area of the Venturimeter one end and other one at the constricted end. So we can find out easily what will be the velocity of the